Good afternoon, everyone, and welcome to the American Floral Endowment's Grow Pro webinar series. I'm your moderator, Michael Wajasinga, and I'm an assistant grower for Bell Nursery in Springfield, Ohio. I help oversee and manage production of a wide variety of ornamentals for hundreds of stores across the country. Today's session is on new technology and pesticides for flower crops. On behalf of the American Floral Endowment, I'm excited to be part of AFE's Grow Pro webinar series that features a new topic every month presented by an industry expert. The webinars are free to everyone thanks to the generous support of AFE sponsors. This session is sponsored by OHP and Syngenta. OHP's mission is to provide high-quality pest control products and services to the greenhouse and nursery production industry in order to provide grower solutions. Syngenta is a leading science-based ag tech company. They help millions of farmers around the world to grow safe and nutritious food while taking care of the planet. If you would like to learn more about our sponsors, or if you're a supplier and interested in becoming a sponsor for a topic, you can find that information on AFE's website at endowment.org/growpro. Today's session was pre-recorded in English by Dr. J.C. Chong. After the presentation, Dr. Chong will join us for a Q&A. Feel free to submit your questions through the Q&A feature or chat at any time. We'll answer as many as we can before the end of the hour. Unanswered questions may be answered through a separate email exchange. This session is being recorded and will be shared to AFE's YouTube account. Through YouTube's accessibility features, you can access closed captions in other languages. To get us started, I'd like to share a bit about today's speaker, Dr. Chong. Dr. Chong is a professor and extension specialist of turf and ornamental entomology at Clemson University. JC joined Clemson University in 2007 after completing MS and PhD training at the University of Georgia and postdoctoral training at the University of Florida. His current research and extension program focuses on developing practical and effective pest management tools and approaches for turfgrass and ornamental plants. During today's sessions, JC will directly discuss some pesticide products. The American Floral Endowment does not endorse any product. However, our researchers do testing and research with industry products and can share their insight and experience. JC, welcome and thank you for presenting today on new technology and pesticides for flowering crops.
Hey everybody, thanks for joining our webinar today. I'm JC Chong, as Mike mentioned. And first I want to thank AFE for providing the opportunity for me to come to talk to you. And also OHP and Syngenta for sponsoring today's webinar. And today what I'm going to talk about new technology and pesticide for flowering crops. And the reason why we started this particular webinar is really to try to figure out how best to do insecticide rotation in some way. And pesticide rotation is a real thing, contrary to a lot what other people are thinking. We have a lot of examples as far as insects developing resistance to different kind of insecticide. One of the most prominent example is the sweet potato whiteflies. And you guys probably remember the B biotype and also the Q biotype. And Q biotype is one of those biotype that are quite resistant to neonicotinoid and insect growth regulators. And so B and Q biotypes together are known to be resistant to about 66 different kind of active ingredient in different parts of the world. And of course, again, I mentioned that Q biotype that were recently introduced are very resistant to some of the insecticide that we commonly use. Here's another example that I deal with personally, which is a spider mite species called hydrangea spider mite in one of the nurseries that we have in South Carolina. So I got this call from these particular growers coming to me and say, holy cow, I cannot control my spider mite population. So I just go take a visit and see what they're doing and see what they've been using for controlling the spider mite population. And what we're finding out is that they have been using AFE quite a bit. And so what I did is get a lot of these spider mite population back to my greenhouse and tested different kind of miticide on them. So what we're finding out is that AFE, which is on this bar, the second group of bars there, basically are not killing as many mites as all the other miticide. To me, it means that this particular population have become tolerant or less susceptible to AFE, unfortunately. So when these growers switch to another product, for example, pylon or floramide, they are able to actually solve the problem and keep the spider mite population down. So pesticide resistance is real, and there's a lot of way that pesticide resistance actually become active or become more prominent in your population. And one of the most common way that pesticide resistance actually develop is through repeated use of the same mode of action or same pesticide over time. So that's one thing that we need to be doing or stop doing so that we can delay the development of pesticide resistance. Now, again, pesticide resistance can be avoided. We don't have to live with it forever and ever and ever. Generally, there are three approaches to pesticide resistant management. The first one is management by saturation. What that means is that you'll be using the highest rate possible. The idea is to kill every single one of the individuals, every single one of the pests, even the resistant one. So you use a high rate to saturate the population and kill all of them. Well, I personally do not like this method particularly well, simply because it doesn't get away from the real reason why pesticide resistance is developing, meaning that you're using the same product over and over and over again. The second approach is basically moderation, management by moderation, excuse me. So this particular idea is, doing everything in moderation in some way. Practice IPM. You only spray when you need to, and you use a lower dose, and also always use insecticide with a shorter residual so that the residual can break down and the insects will not in contact with the residual all the time to increase their population. And also you create a refuge basically for the susceptible population to maintain the genes so that they can crossbreed with the resistant population and dilute the concentration of or the chance of your resistant development. So that's another approach. And the third approach is management by multiple attack. The idea behind this particular approach is that you would challenge the pest population with different mode of action or multiple attack so that you can overwhelm them. You can either do this using tag mixing, or you can do it with pesticide rotation. So if you're like me, being around for a while, you want to put a stamp on everything, obviously. So for JC, he also have his own recommendation in some way. So this is actually my recommendation, sort of a combination of moderation and also multiple attack. So what I would recommend as far as pesticide resistant management is, first and foremost, is practice IPM. Make sure that you do not rely only on insecticide. You want to think about biological control as well if the option is available. So think about that. The second thing is to spray only when you need to. And the third thing is you want to make sure you achieve excellent spray coverage every time, because any little pocket that you do not spray, you are leaving some individuals there so that there's a chance for the population to actually propagate. And fourth thing is to practice insecticide rotation. That's very, very important. And we'll spend a little bit of time on that. And the last thing would be that I would typically recommend avoid tank mixing. If you want to tank mix, you could, but only under very specific conditions. You only tank mix when you are dealing with different life stages. And in that case, you basically have to use different kind of insecticide. One of them more effective against the adult, the other one more effective against the eggs. Put them together, then you can have full coverage. Or if you are dealing with different pest species, for example, you're mixing an insecticide against thrips with another insecticide against mealybugs. Two of them mixed together, you might get result there. So those are some of the situations where I would recommend that you use tank mixing. As far as pesticide rotation, here are some of my recommendations as far as how to do it. I would recommend that you rotate to an insecticide of a different mode of action for each generations. And that means you need to know how long your pests actually develop. For example, if you are dealing with a spider mite population, you might have to rotate to a different mode of action at every single spray if you spray every week. But if you're dealing with a mealybug, which have a much longer duration of development, you can actually use the same product or the same mode of action for the same generations, subsequently. So you could actually do that if you wish to. But I would definitely recommend that know your pest biology so that you know when you want to rotate to the next mode of action. And my second recommendation when it comes to building a pesticide rotation program is to consider including a physical mode of action pesticide. What I mean by that are including a horticultural oil or an insecticidal soap. Horticultural oil and insecticidal soap, they kill by suffocation or cell disruption. So there's no way for the insects to actually develop resistance to those way of killing them. So in that case, they have a very low chance of developing pesticide resistance. If you mix this physical mode of action pesticide in the rotation program, you will get much better or longer rotation program efficacy. And the third thing is, I would recommend that we start the rotation program with the most effective product and application rate. That does not mean the highest application rate. What it means is that you need to know the life stage and choose your product carefully so that the product you choose are most effective against that life stage. And choose the application rate that is most effective against that life stage. Knowing that adult usually are tougher to kill, in that case, you probably need a higher application rate so that you can use that against the adult. Nymph, easier to kill, then you can use a lower application rate. And the fourth recommendation is, if you are going to be drenching a systemic insecticide, you do not want to spray with the same mode of action after that. So if you drench it once at the beginning of the crop, stay off that mode of action for the rest of the crop season. And the last thing is, if you want to do tank mixing, you want to mix different mode of action in the same tank, not the same mode, not two products of the same mode of action in the same tank. Use different mode of action. And if you're going to do another tank mix a week later, you want to make sure that you're tank mixing two other different mode of action in that same tank. So those are my recommendations as far as pesticide rotation is concerned. But before we can actually build a pesticide rotation program, we need to know what kind of mode of action we're talking about. Now, when it comes to insecticide, right now we have 34 known mode of action classified by IRAC. IRAC is the Insecticide Resistant Action Committee. So right now, of all the insecticide out there, IRAC were able to classify them into 34 different mode of action. And also, there are some pesticides that we don't know anything about their mode of action. So those are classified as the unknown mode of action. And there are also some biological that were classified in different categories. And there are some that are not classified at all. So anyway, of all these mode of actions that were classified by IRAC, you can sort of group them in 5 different categories, so 5 different groups. The first group is the nerve and muscle poisons. So these are actually the ones that disrupt the normal neurological function of an insect and basically cause paralysis and death later on. And the second group are the growth regulators. The growth regulators will actually stop the development of insects or stop them from laying eggs. The third group are respiration and energy production inhibitors. And these kind of insecticide will go deep inside the insect tissues, disrupt the normal function of mitochondria so that the insects cannot produce any energy at all. And in that way, the insects usually become lethargic and eventually die. And the fourth group are the midgut actors or midgut stomach. And this would only include one mode of action, which is a BT, which actually rot the gut of the insects. So it's interesting. The fifth one would be unknown or non-specific mode of action. So there are so many mode of action out there. How do you know which one you have? Well, that's actually pretty easy to find out. So most of the new insecticide label now actually have the IRAC group number prominently displayed on the first page. For example, Saloprin. This is a product by Syngenta, and right on the top of the trade name, you will see a box that's stated is active ingredient and group 28 insecticide right there. So if you see that group 28 insecticide, then you know that is IRAC group number. Here's another product, Palladia, by another sponsor of ours, OHB. And in this case, Pladia is a combination of two active ingredients, cyclinylipole and flornicamide. So on the top label, you have two numbers, 28, which is cyclinylipole, 29, which is flornicamide. So all these products, depending on the active ingredients, will actually have everything prominently displayed. That's not a problem for you to find them. So don't worry about that. All right, here's another product called Altus by Bayer. And what you see is that the group number is 4D. Now, 4 is the number of the mode of action, but D indicating its chemical class or family within that mode of action. So you can actually tell both the mode of action and also the chemical class in some of the product. So let's think about how to build a pesticide rotation program. How about that? All right, let's do a little bit of exercise and take a look at this particular rotation product. Let's just say I am grower number 1. I want to control a population of whiteflies. I heard JC said that Safari and Altus and Mainspring, they're all pretty effective against whiteflies. So I decided to put all 3 of them in my rotation program. So I started with Safari, then 2 weeks later, I spray Altus, and 2 weeks later, I spray Mainspring. So is this an appropriate rotation program? The answer is no. Why? Because Safari and Altus, they both have IRAC number 4. That means that they're actually the same mode of action. So you should not put 2 products of the same mode of action in a rotation program. Let's try this one. All right, well, okay. I'm not going to use Altus. I'm going to change it out. I'm going to use Pladia instead. All right, so Pladia, and then 2 weeks later, I'm going to do Safari, and then 2 weeks later, I'm going to spray Mainspring. Is that an appropriate rotation program? The answer is no. Why? Because Pladia is 28 and 29, and Mainspring is 28. So here you actually have 2 products with the same mode of action, and that is not an appropriate rotation program. Let's look at another example. All right, okay, let's change something out. So let's do Safari first, and then 2 weeks later, I'm going to spray Rycar, and then 2 weeks later, I'm going to spray Mainspring. Is that a good rotation program? The answer is yes. In this case, your 3 products, none of them have the same IRAC number. And therefore, there you have it. You have a proper rotation program. So we have a lot of products out there that can be used for a lot of different kind of insect species. So it is not difficult for anybody to really build a rotation program because there's so many mode of action code out there. So always think about it. If you're building a rotation program, just make sure that the products are not the same. Okay, so a lot of folks often ask me, well, how many products do I need in a rotation program? I say 3 at the very minimum, but if you can do 4, that's even better. So you could actually definitely do either 3 or 4, but always remember that the IRAC number within the product that you choose should not repeat themselves. All right, next, what we're going to do is to actually go through a few products that were introduced in the past 3 years or so. And I'll try to share with you some of my experience working with these products, what they're good for, what they're not so good for, and so on. All right, the first product I want to mention is Altus. This is a new product, relatively. The active ingredients is fluplyradifuron, and the IRAC number is 4D. Remember that 4D is in the same mode of action as a neonicotinoid. And it is a systemic product registered for use for landscape, nursery, and greenhouse as well for both ornamental and vegetables. A lot of its target pests are actually sucking insects, such as aphids and mealybugs and whiteflies and thrips. And Altus, in my experience, works pretty well against sucking insects. So if you do not want to use neonicotinoid and want to find a replacement, Altus is one of the options for replacing neonicotinoid. You can drench them and it will do quite well against a lot of the sucking insects. Now, I do need to mention that Altus typically moves slightly slower than the neonicotinoid, so you may not see a pest reduction as fast as the neonicotinoid. So be aware of that. All right, the second product we want to talk about is cyclinilipol or Sarisa. Sarisa is a product by OHP, and it is from the IRAC group 28. So it is in the same mode of action as mainspring and azaliprin. So Sarisa is registered for use in greenhouses and nurseries for ornamentals and non-bearing crops. And again, Sarisa is a systemic insecticide. You could use it for sucking insects such as aphids and mealybugs and soft scales and whiteflies. But you can also use it for some other chewing insects such as caterpillars and leaf beetles. One of the work that we have done with Sarisa in the past is trying to figure out if Sarisa works well against scale insects. So what we're finding out is that we're stacking Sarisa up, compare that to some of the efficacy of our commonly used insecticide for scale insects. And what we're finding out is that when you're using Sarisa for scale insects, it will work, but you do want to consider using a higher application rate. Another product next is almost like a cousin of Sarisa. It's introduced by OHP as well, and it is a combination product, cyclinilipol plus vernicamide. So it is a group 28 plus 29. And the use site is greenhouse and nursery. And the target pest spectrums are very similar to Sarisa. And but one thing that Pladia do especially well compared to Sarisa is its efficacy against mealybugs and also thrips. Some of the data that I've seen and some of the data that I'm collecting right now is suggesting that Pladia will work quite well against mealybugs when they are used at high rate. The next product is called azaliprin. Now, some of you probably think, well, azaliprin, I've heard of that for a long time. Well, that is very true. Azaliprin has been around for a long time. But recently, Syngenta actually make this product available to the nursery and greenhouse industry. And azaliprin is also a group 28 insecticide. And currently it is registered for nursery and greenhouse production for control of caterpillars, white grubs, and some of the sucking insects such as aphids and lacebugs, excuse me. Now, azaliprin, I've worked quite a bit of it with control of caterpillar particularly, and some of the work that we have done with European pepper moth showing that one application of azaliprin will give you 4 weeks at the very least of suppression of the European pepper moth population. So this is one of the products that give you very long residual against caterpillars, and with one application, well, you don't have to worry too much about the infestation for a long time. So that is a great product to use if you want to save some labor costs. Ventigra is the next product, and this is a new product by BASF, phytopyropin. The IRAC group number is 9D. It's registered for use against sucking insects such as aphids, whiteflies, for landscape, greenhouse, nursery, and interior scape against sucking insects on ornamentals, vegetables, and also transplants as well. And this is a very effective product against aphid species. We have run trials on this particular product against several different aphid species, and all of them works very well. Velifer is another product by BASF, and this is a product that contains Bovella bassiana. And this is a different strain of Bovella bassiana than the Botanicard. So currently the use size for Velifer is greenhouse only, but you can use it for ornamentals, vegetables, and also vegetable transplant. And the target pests are aphids, whiteflies, mealybugs, mites, and also thrips. Impede is a very old product. It has been around for a very long time. But last year, that actually receive a different recommendation, a different use, which is called the pre-plant dip. So you can actually dip your cuttings before you stick them with a mixture of impede at 0.25 to 0.5%, and you can use that to control whiteflies and spider mites. And some of the work that we have done show that if you mix impede with Botanigard, for pre-planting dip, you can actually produce poinsettia cuttings that have very, very, very low whiteflies density for 8 weeks after dipping them. So a combination of Botanigard and impede before you stick can give you a lot of protection. It will wipe out some of the whiteflies populations on those cuttings, and just to give you a clean start on your crop. The last product I want to talk about today is Hexagon. Hexagon is a miticide, and Hexagon has been around for quite some time. Gowan, which is a company that manufacture Hexagon, introduced Hexagon IQ quite some time ago. Now, Hexagon is IRAC Group 10A, and last year, Hexagon also received a 2EE recommendation label for pre-planting dip against spider mite at the rate of 0.08 ounce per gallon. So at that very, very low rate, you can dip your cuttings either rooted or unrooted, and in some of our trials would actually give you very, very clean plants by wiping out some of the eggs and also some of the nymphs on those cuttings, just so that when you actually grow those plants, the plants will grow up with very, very low spider mite population. All right, so that's all I have for today. And I hope some of you actually will learn something from the talk today. And if you have any questions, do feel free to ask.
Thank you, JC. I'm going to go ahead and open it up to our Q&A now. So our first question here is resistance management by saturation complicated by the fact that application coverage is never 100%?
Well, that's good. And actually, the poor, excuse me, poor coverage, poor spray coverage actually complicate resistant management. It doesn't matter what kind or what approach you actually take, whether it is saturation or moderation or multiple attack, because if you do not create a complete coverage, meaning that there's going to be some kind of refuge left behind. And in that sense, you can kind of talk about it in two ways in some way. So refuge, one way refuge could do is that it would actually preserve some of the individual that may be susceptible to the pesticide resistance, and when it actually mix with the one that's resistance, it will reduce the level of the resistance. So in some way, a refuge is good, but in another way, it could be bad because it would actually allow more individuals to be contacting a residue that's less toxic and make it easier to actually result in resistance. So there's actually a lot of research going on, what actually happened already, that try to look at what happened when you have a refuge. Right now, there's not a whole lot of consistent conclusion as far as what the effect may be. And unfortunately, a lot of these research are actually done as a modeling exercise, meaning that there's not really any sort of insect population that's involved. They just crunch the numbers on the computer and then you run the models and see what happens. And we all know when it comes to running model, it's a lot easier. But if for model to actually emulate what is happening in the field, it could be a little bit tricky. So anyway, that's a good question. And the best answer I can give you right now is we don't really know. It could cut both ways. We don't really know exactly what it might end up. So a lot more research actually needs to be done for sure.
Awesome. I'm going to go into the next question here. So given the relatively new products on the market, what would be a good rotation of chemicals to use for crops heavily susceptible to mite infestations? And then it continues, would that rotation change if you also had thrips and mites?
Right. So what I presented today a lot of it is really based on, you're thinking about a single individual pest population or single individual pest species. So in that case, you could kind of build a relatively simple model, simple rotation program in some way, one at a time. But we all know that it is just about impossible to really deal with just one pest at a time. And whenever we are growing something, not only are we dealing with spider mite, maybe it's a thrips at the same time, and then maybe the aphids at the same time. So each one of them would have to be sort of tailored and designed in some way. Of course, one of the recommendations that I provided still works, which is you want to use a physical mode of action, meaning soap, meaning oil, and those can be used against multiple different pest species. So that's one way for you to angle your rotation program based on those physical mode of action, for sure. And of course, there are some other products that can control multiple pests as well. You could actually use them using one product against multiple pests at the same time. You could do that. Or another way would be to do tank mixing. So this is one of the situations where I think tank mix actually makes a lot of sense, which is when you're actually dealing with different pest species. You can have one product and for one pest and product for the other pest, mix them together, and you deal with two different species at the same time. But do remember that whatever you use in this particular tank mix, the next time you spray, you want to switch it to a different mode of action, of course. And in the instance, and of course, don't forget biological control. Biological control is a great way to deal with a lot of pest species if there are some options available, because insects or mites cannot develop resistance to something they eat them. If the biocontrol agent can chase them down, kill them, or infect them, that's no way for the pest to get away. So biological control is also a good way to actually really try to reduce the pest population, reduce reliance on pesticide, and then do a better job in controlling pests, for sure.
Awesome. Yeah, biocontrol is a lot of fun.
Yeah.
Learn to use it a little bit here. So I got a really good follow-up question for that. Do you have a recommendation on where to find information on biocompatibility using beneficial insects with pesticides?
Right. So one of the good source of information really is your biocontrol agent supplier. Wherever you buy your biocontrol agent from, for example, Cobra and BioBest, they keep a side effect manual or side effect database. So they can actually whip that out pretty quickly and tell you what product you could use and be compatible with the biocontrol agent. So that's where I would start for sure. And really that would be the best place, I think, is to talk to your supplier, and because they know their product, they should be able to know how to use them well, and be able to tell you what other pesticide you can use to deal with it.
Cool. So another question here from Catherine. For submerging cuttings, do you recommend mixing MP and hexagon, or is one more effective than the other for a single application?
All right. So question is, impede hexagon, which one is better for dipping against spider mite? I would think that both would work just fine. And it would be a good idea for you to actually look at your cuttings and see what life stage it actually is. Because remember that hexagon is a mite growth regulators, meaning that they will be more effective against the eggs and the little guys. It's not going to kill the big guys. It will reduce the number of eggs produced by the big guys, but it's not really going to kill them. So if you have a mixed population of both the eggs and the nymphs and the adult, I would probably go with the 40% oil dip. And if it is something that's mostly just eggs or mostly just nymphs, I would go with the hexagon dip. So either way, you'll be fine.
Awesome. Do you have that paper that you have with the Botanigard and the MP somewhere posted online? I know there was a really good chart that was in your
right, and that is actually published in Grower Talk. You know what? I don't remember exactly what it is, but I could probably find out and put it on the chat box later on.
Awesome.
For sure. But Chair, just kind of type in my name, JC Chong, Grower Talk. something might pop up.
So another question I have here. I noticed that in the rotations, the examples you gave today, that you had 3 of them. Is that a number of products we should use, or is there like a key number of products that we should be putting into our rotational programs?
So my recommendation as far as how many products you want to include, the minimum is 3. If you have just 2, they're just back and forth, it is not doing anything. So the minimum number is 3. And for today's presentation, I just used 3 because it's a lot easier to discuss it that way. But certainly, if you want to have 4, great. If you want to have 5, that's also good. There's not really any there's not really any like magic number as far as how many mode of action you want to put in. As long as you rotate, you and I will be friends.
Cool. Here's another question. Does oil have a dipping rate? You mentioned it.
Right. So the oil, well, typically for the dipping, for the cutting dip, what we do with oil is 0.1%. Some of the work that's done in Canada, they have tried different rates. And the typical spray rate, which is 1 to 2%, totally burn those cuttings. So don't use that. 0.1% seems to be one of the rates that's most safe when it comes to phytotoxicity.
Oh, sweet. And then I see Nick Flax here just shared. Yep, awesome.
Yep,
So
there
Nick
you go.
Flax just shared the article from with MP and Botanigard. So everyone should have it down there in their chat box. So
Right. One thing that we have tried with the impede and Botanigard, in fact, Rose Bitterhouse, her group up in the Vineland Research Station in Canada, they are the one that really did a lot of work with dipping. And what they're showing is that if you know that cutting coming in is going to be infested with different kind of pests that's hard to see, go ahead and dip them. After you dip them, stick them, let them grow. And what they're showing is that not only do they keep the pest population relatively low or even not there for a long period of time, in some cases up to about 8 weeks or so. But even during those times, if you follow it up with the biocontrol agents, the biocontrol agents actually help to further reduce those pest population. So that's one way that in Canada, they can actually very successfully do biocontrol agents, because first they reduce the pest population pretty low. And then they are using pesticide that doesn't have very low residual. And that way, whatever you release onto those poinsettia or whatever cuttings that you use, those biocontrol agents are not killed by the pesticide residue. So that definitely helps with the starting clean, staying clean kind of approach, I guess.
I love that. Yeah, I've been burned by not starting clean and done really well starting clean. So
well, yeah, and I hate to say it, for those of us that get a lot of cuttings from offshore propagations, there's something that we really need to watch for, which is infested cutting coming in. I'm not trying to pick on them, but we have a lot of examples, stuff coming in that way.
So here's another question from Lan. I'm guessing this is referring to the use of oil for dips. She was asking if the US label has been changed.
Right. In fact, the oil label right now, soft oil X, probably going to have a label change soon to indicate those. Impede already have the 2EE recommendation. That's not a problem there. And then Hexagon, that's not a problem there. And Botanigard, which is another product that we typically mix with Impede for dipping, they already have the cutting dip label or language on the label. So it's definitely coming, and everybody will be pretty legal doing that.
Cool. Yeah, and I guess a little addition there. I heard last week, as of Q4, we should expect soft oil to be
Yes,
labeled in the US.
It's
so
coming pretty soon.
our guys were telling,
Right.
guys were telling the truth to me. So another question here from Nick Flax. Have you seen any increase in incidences of bacterial pathogen pressure like Erwinia, Pectobacterium, I don't know how to say this one, Dicea, when doing these MP and Botanigard dips?
Well, that's a good question, and that is something that I don't keep up with very much, but there is definitely concern that cutting dip is going to end up becoming a problem, spreading a lot of these bacterial diseases. So kind of have to start with pre-clean cutting first, to make sure that we don't have any sort of bacterial infection at all. But I don't keep up with exactly what other fungicide that you can put in there to actually prevent that from happening. But I think that some of the fungicide, particularly copper fungicide, you might be able to use along with your dip solution, just to make sure that the bacterial diseases doesn't spread so much. And and of course, every time you dip a cutting, you want to make sure that between batches, you want to take care of those dip solutions. You don't want to use the same batch of dip solution for days and days and days and days. That is a recipe for disaster for sure.
Awesome. So I have, I know earlier in your presentation, you mentioned about starting your rotational program with your most effective product. Would you be able to circle back and just kind of explain a little more about that?
Right. So what I mean by the most effective product is, not necessarily the highest rate. What I mean by that is really think about what kind of issue you have. For example, miticide. The miticides are not created equal. I always say it that way because some of the miticide actually works better for a particular life stage than the other. So when I mean most effective product, I mean, look at what you have, and then look at the life stages of the pest, and then select the insecticide or fungicide or miticide that actually works the best against that particular life stage. That's very important because if you ended up using a less than effective rate or use a product that's not as effective for that particular life stage, not only are you not getting the right control, you're also allowing those mites and insects to be exposed to the residue, and then they ended up become resistant over time. And that's probably not the best way to go about. So if you're going to start with any kind of rotation, I'll definitely start with something that actually works well, knock the population way, way down so that everything else behind it can work a lot better.
Awesome. All right, if we're going to take a few more questions. If you have any more, feel free to submit them now. I'm going to go to one over here. You mentioned that a rotation program should have a physical mode of action in the rotation. Can you just explain what that kind of means again?
So what I mean, when I mean physical mode of action, those are pesticides that are basically horticulture oil or insecticide soap. So what they do is that they either suffocate the insects or they will seep into the body of the insects and basically disrupt or kill the cells inside their body. So they don't really typically depends on actions on the neurological system, neural system, or they don't depend on messing up tiny little parts of their biochemistry. So what they do is basically suffocating. So think about it. If somebody cover your mouth and nose and don't let you breathe, it doesn't matter whether you're resistant to a handkerchief or not. You're gonna die either way. So if we are using something that's suffocating them or destroying the cells physically, there's no way the insects can develop any sort of resistance to get that kind of mode of action. And so the chance of any insects developing resistance for oil and soap is very, very, very low. And so if you include that in a rotation program, you can kind of make sure that there's one piece of that puzzle that the insects have no chance of developing resistance to. In that case, your program would last a lot longer and a lot better.
Awesome. All righty, JC, I want to thank you for an awesome presentation. I think that wraps up our questions, and thank you for the awesome answers and insight. I'd like to thank all of our viewers for joining us today for another session of AFE's Grow Pro webinar series. Feel free to join us next month for Dr. Chris Curry's presentation on finishing your poinsettia crop successfully on Tuesday, October 18th at 1 p.m. Eastern Time. You can register at endowment.org/growpro. While you're there, check out our past webinar recordings, other related resources, and research reports available for free thanks to industry support. We ask that you please complete the brief survey about today's session, where you can suggest additional topics and help us continue to improve these webinars. Thank you again, everyone, for joining us, and have a great day.